Hi everyone and welcome. We are HackSussex, the Computing and Technology Society at the University of Sussex. Since our founding back in 2012, we've been at the heart of the university's tech community, supporting computer science students and enthusiasts in their university experience, running events for students all across the country. This year we hosted events for over 300 people, and we hope you all had fun. Behind these events is a committee of 15 dedicated students, all different year groups and degrees, each bringing their unique skills and perspectives to the table. Our aim is simple, to bring people together through a shared love of technology. Whether you're passionate about programming, building robots, gaming or other tech interests, we are the society for you.
We're proud to run 3 flagship events across the academic year: the Game Jam, the Hackathon and the Coders Cup, which is why you are here today. Every single one of these events is planned and executed entirely by the HackSussex committee, working alongside a wonderful team of volunteers and with the support of the informatics department. But it's not just the big events. We also host weekly socials, giving Sussex students the opportunity to relax, unwind and connect with fellow students after a day at university.
Each committee member plays a vital role in bringing our vision to life. From logistics and sponsorship to creative direction and technical support and event screen printing our own merch, there's a role for everyone here. Before we officially start the Coders Cup, let's take a look at what we've been up to this year.
The Game Jam kicked off our year and took place in early December. 24 hours of non-stop game-making chaos, creativity and pure fun. Participants teamed up to create incredible games from scratch in just one day. Every year we are absolutely blown away by the imagination and technical skill on display. Throughout the event, we hosted engaging workshops, mini challenges, and of course, tons of free food. Everyone's favourite part. This year's Game Jam was our biggest yet, welcoming a record number of students and graduates to the computer labs here at Sussex.
Then, at the end of February, we hosted our main hackathon. While our Game Jam focused more on games, the hackathon invites participants to build absolutely anything you can imagine. We welcome brand new sponsors such as Unity, London Gatwick Airport and Sussex AI, as well as our long-term supporters Hastings Direct and BCS. This year's hackathon was amazing, receiving more than 50 project submissions and ending with 18 teams returning home with a prize.
And now that brings us to today, our grand final event of the year. The Coders Cup happens live on YouTube and unlike any event you've experienced before. After weeks of qualifiers, the top 8 coders here at the University of Sussex are going to solve challenging problems in real time. They are all competing for the ultimate title, the Best Coder at Sussex 2026. This is your chance to cheer on your favourite coder, participate in our giveaways and chat with the community. But I won't spoil the excitement of what you're about to see. So without further ado, let's hand things over to Richard and Lukas in the studio.
Take it. You got it. I got you.
Oh, we're live.
Oh, bubblegums!
Welcome to HackSussex Coders Cup 2026. This is our final event of the year and we can't wait to get started. Whether you're a returning fan or new viewer, we hope that you're going to enjoy the next couple of hours with us.
We'll be here every step of the way until we find out who is deserving of the coveted Coders Cup trophy and, of course, the eternal glory and bragging rights. First things first, Pac-Man lovers, my name is Richard, and I am a third-year ComSci AI student here at the Sussex University, and it's an honour to be presenting again on behalf of Sussex.
Not everyone loves Pac-Man, Richard. Personally, I think Tetris is far more popular. Anyways, I'm Lukas, a final year ComSci and AI student at Sussex, and I'm into robotics, game development, also dabbling in competitive coding part time. Myself and Richard are thrilled to be bringing you the live Coders Cup finals.
Over the past few weeks at Sussex, participants have been battled in an intense series of qualifiers, and after some serious button mashing, the top 7 coders have been selected here to battle it out arcade style to be crowned the best Pac-Maner.
Whoa, this isn't a Pac-Man tournament, Richard. I think you mean the best programmer at Sussex.
Oh, sorry, Lukas. I've been told sneaking in a few power pellets in my diet. Anyways, our delightful coders are eagerly waiting for our intense battle. Without further ado, let's meet them.
Absolutely. Zee is in Studio 2 with our finalists. Over to her to see how they're doing.
The Thank you guys. I'm Zee, a second-year computer science and AI student at the University of Sussex. I'm here with those very finalists, but although there's 7 of them now, only one of them will be walking away with the title of Best Programmer at Sussex. I will be interviewing the contestants throughout the competition for you to giving you the exclusive insight into how everyone's feeling. Stay tuned with us for the live reactions from our coders. So guys, are you ready? Yeah! Woo! Great stuff. Back to you, Lukas and Richard.
Thank you, Zee. It's game on as our contestants enter a bracket of high-stakes head-to-head battles.
This will be a single elimination tournament where each win earns them more prizes as they climb up the Donkey Kong ladder.
But be careful not to hit the barrels or you won't get your hands on the grand prize. These contestants are loading into a mental dungeon packed with algorithms, game theory, and extreme mathematical boss fights.
Oh, you know what they say, Lukas? Great bosses come with great loot.
But don't get carried away. We want to see clean, fair play. That means all the contestants have to abide by the rules.
Oh, let me whip out the delicious book of rules. Bah.
We're running 12-minute games with no internet allowed. Looking at you, ChatGPT.
The coders will only have standard access to the library and the documentation of their chosen language. They can't cheat with the Konami code.
Both coders are presented with the same questions to answer in the allotted time.
They'll be given a number of boss fights.
Test cases.
And the winner will be the one who comes victorious to all test cases first.
However, if neither player passes all test cases, whoever passed the most test cases within the time limit will achieve victory.
Ooh, speedrunning. I love the sound of that. Anyways, that's all the rules, folks.
We would like to give a huge thank you to our sponsors, Unity, Switchplane, the Department of Informatics, and BCS, making this event possible for all our viewers. And we're excited to share more details with you all later in the show.
Our coders fought hard in the qualifiers to get their place here today.
Indeed. Here's the top 8 of the HackerRank leaderboard. In 7th place we have Ella with 34 points.
In 6th place is Jessie with 39 points.
Our 5th place player with 40 points is Henry.
In 4th place is Ash with 67 points.
We have Jake at 3rd with a score of 87.
And our 2nd place seed is Gibson, who has very quickly gained 102 points. Will our surprise candidate give the veterans a run for their money?
And finally, coming on top with 146 points is Ozodbek, being a solid 111 points ahead of 7th place. They are clearly the one to watch out for.
That's all the coders ready to fight in the bout of the year!
We also have some exciting giveaways for you guys at home or in the arcade to win some free Steam vouchers. These giveaways are open to everyone, so keep your eyes peeled during the stream.
To get into our first giveaway, you, our dear viewer, have to show us that you are eagerly watching by participating in our live chat. Tell us your solutions to the questions in the chat, and we will follow on our fellow viewers with a chance to win. The winners will be announced at the end of the qualifiers.
Good luck to everyone. Now let's look at the tournament bracket. Round 1 is Jake versus Jessie.
Round 2 is Gibson versus Henry.
Round 3 is Ash versus Ella.
And Ozodbek advances straight through the semi-finals. Let's close the brackets already. Let's get into the games, Lukas.
To congratulate our 7 finalists, they will all be going home with a HackSussex goodie bag containing a commemorative t-shirt and a mug almost as beautiful as Richard's.
That's deja vu. Anyways, the victors of this first round will be walking away with their Atari game console, plus anything they will win later on in the rounds.
That's seriously cool. The prizes only get bigger from here, so stay tuned. Alright, the first matchup is about to begin.
Ah yes, it's game time!
Let's see the first 2 competitors.
Oh, it's Jake versus Jessie!
This is going to be a fun one.
I agree. I mean, we have Jake with Python.
Jessie also with Python, so 2 Python lovers here.
Oh, that's obviously because Python is always the better language than C or any other
language.
I'm
not too sure. I find C++ pretty good myself.
But this is a quite interesting matchup. You see why? Because Jessie is actually a physics student.
Yeah.
I wonder if they know about the gravity of the situation.
Okay. Well, let's meet them now. Over to you, Zee.
I'm here with our first competitors of the day, Jake and Jessie. So Jake, how are you feeling?
I'm feeling good. I'm excited to win. Yeah.
We love the excitement. And Jessie, how are you feeling?
Nervous, but I'm really happy to be here.
Exactly, being grateful. We hear you own 7 bikes. Can you tell us a bit about that?
It's the best way to get around in Brighton, let's be honest, and it beats walking. And they're cheap Facebook Marketplace, so there's nothing wrong with a bit of cycling.
Honestly, I think I hear what you're saying. I might try get one. Facebook Marketplace. Great. Please take your seats behind me. Let's get ready for the first competition of the day. Guys, first competition of the day. Tensions are rising. There's nerves, there's excitement. I wouldn't even know how to feel being the first competitors of the day. They sound confident. They sound ready. It's definitely going to be an exciting one. Who do you guys think is going to win? Let's see who actually knows how to code and who maybe uses some ChatGPT. Now, I'm ready. They're ready. Are you at home ready? Let's kick this off in 3, 2, 1, code!
And that is the first round of the 2026 Coders Cup!
Exactly, let's get into it. So this question is goal parser interpretation. The problem asks you to translate a string that's made up of 3 tokens, G, parentheses, and parentheses with AL inside of them, into their plain text equivalents G, O, and AL. And then you have to concatenate the results. So it's basically a translation question.
I mean, in my opinion, I think I'll be using something of a map function to a lambda function to essentially map the G with the according string literal.
Yeah.
And again, iterating through all of them to the string.
The description makes it look quite heavy, but in truth, there are actually quite some simple solutions you can do for this, especially with 2 Python participants here. You could quite easily solve this question with a single line using a couple of replace functions.
Oh, we can see that Jessie has started within a final, so already looking into the final case rather than the starting case. An interesting approach.
Jake is seeming to be using a while loop, which is an interesting approach.
Oh, I was thinking of something of a while loop. I mean, obviously a string is just an array of characters.
Yeah.
And if you just go through them again and again and then replace the character G with the literal G and the parentheses with the O's,
yeah,
then they should be able to solve it.
The thing to watch out for here with a loop is because each token isn't a single character, you would have to get a substring, which can lead to maybe more errors when you're checking indices.
Fair. I mean, errors in indices, that is an errors out of bounds for me. I mean, I wonder who's gonna first win, but here you can see Jake is really speed running through the whole code. And has he gotten any test cases, you think?
No test cases so far.
Okay.
Seems both participants are deep in their coding.
I see that the top processors are top processing. Here we have an if statement if the command is lower than A. So basically changing all the characters into one case, which is a very smart move because these different cases makes the code more complicated. But instead, if you change everything into a lowercase, then you can easily find out what letter, just the letter, not the case itself, which is very, very smart from Jake.
Yeah. Jessie, the physics student, seems to be also switching to a for loop.
Oh,
using some if statements to catch
we have
the
our
tokens.
First run. From Jake, we have our
first run.
Yes, we had a 4 in, but now it's 4. Oh, Jake made a major mistake there to make it.
A few test cases pass.
Just a tiny bit, like a droplet of test cases. But here in Jessie hasn't run anything yet. But instead of using a while loop where Jake is, what is Jake doing? And for loop for Jessie. So, and you know what they say? A wise man used to say, a for loop is indeed a promise.
Exactly, Richard. And one thing to keep in mind is if Jessie doesn't submit any test cases and the game ends, then Jake will take the win with his 14 test cases.
Well, I'm pretty sure now it's 4. They started with 14 and then now to 4.
Still more than 0.
And that is true. I mean, I think Jessie is trying to take it all in one snatch. Like a quick, a net over the whole thing and just snatch it. Oh, and
wow,
Jake
Jake wins.
Oh my god. That was actually a really fast round.
That was quick.
I mean, Jessie didn't even run a single time.
Yeah.
I mean, that was a really, really impressive stuff from Jessie. But let's see how Jake feels about his win.
Over to you, Zee.
Congratulations, Jake! You're officially our first semi-finalist, and we will see you next round. Unfortunately, Jessie, You haven't made it through to the next round, but there's no way we can let you go home empty-handed. So we are going to be giving you a lovely bag with this year's Coders Cup shirt and mug. Is there anything you'd like to say before you go?
Well done. That was so quick. Know how you did that.
Wow, we love a healthy competition. Now, that's all from now. Let's get back in to Richard and Lukas in the studio.
That was a very impressive game.
I agree. I mean, Jessie being a physics student, also being able to be in this tournament and participating and being in the leaderboard itself is an impressive feat. But in the game itself, Jake already started with the fast test case and achieving 17 test cases. And then afterwards, Jake dropped down to 4.
Yeah, it seems that Jake very quickly understood the question and started implementing his solution in his for loop. It's quite impressive that he managed to get indices right the first time round, especially when looking ahead in a string that might overflow.
But nonetheless, Jessie had the right idea, but didn't execute the code at all. That was a problematic thing, because if Jessie didn't run the code, then Jessie would have automatically lost anyway.
Exactly.
But Jake, being really fast at his work, did it perfectly.
Yeah. Well, let's have a look at the next matchup.
And here we have Henry versus Gibson.
We do. Henry, being an ex-committee member of HackSussex, we'll see if that gives him any edge on this tournament.
I mean, he's also a AI PhD student, but I don't think that's going to give him any extra edge. But Gibson is also a computer science student.
Yeah.
So I think Gibson has more chances of winning this round than Henry.
Well, let's find out.
Let's find out.
Over to you, Zee.
I'm here with the next two competitors, Gibson and Henry. So Gibson, how does it feel to have made it this far?
Well, I mean, I kind of just signed up to the hacker rank, and then that's all I really needed to do to get here. But yeah, it feels pretty good.
You're feeling confident? A good sign up was a good decision. And taking on Gibson is Henry. Henry, how confident are you feeling?
Honestly, not very.
I'm sure you'll do well, don't worry. So, great. Please take your positions behind me. We're gonna start the competition soon, so if you guys just head on over. Guys, tensions are rising after that first intense and rather quick first round, I'd say. So let's see if they can keep up the same energy. Let's see how well they do. They both made it this far, so regardless, it's all good. It's time for the next game. I'm so excited to see what happens. And so let's begin in 3, 2, 1, code.
Now we're off with the second game of the tournament.
Yes, I'm very, very excited. This is clear digits. For this problem, you have a string of letters and digits, and every time you see a digit, it destroys itself and the closest letter to its left. Keeping doing this until there are no digits left. What is the remaining string? Oh, that's quite a difficult question. In my eyes, I will probably take the digits and then go in the front, or check the front character and check if that is a right answer or not.
Yeah, the thing to watch out for here is because you're given a string, if you're iterating over it and then delete a part of the string, well then your iteration breaks. That's important to keep in mind here.
Or maybe you could keep it into an array format.
Potentially.
Let's see what the participants are thinking about.
Yeah, Gibson seems to be thinking a bit more in detail about what he's going to write down. Henry jumping ahead with writing an enumeration loop.
Oh, I've just realized something. The question specifically says to its left.
Yes.
Meaning it will be the backwards character, not the front character. So that's going to be an interesting... let's see if the participants catch on to this little nuance.
Exactly, it is quite a nuanced question.
It is. Let's see. So we have Gibson starting with a list and all the digits, and going through a for loop that's going through this string list, and using the isNumeric function. So just checking if it's a number, and then appending that digit to an array.
Yeah, so, well, let's go through some examples. So, for example, if the input was a string ABC, Well, there's no numbers in that, so you just return ABC. But for example 2, if the input is CB34, well, you would go through that loop and realize that 3 is the first digit you went into, so you would remove a 3 and remove the B, the character to the left, and then you'd be left with C4. So you would go through your loop again and realize 4 is another digit and remove 4 and C, so you're left with an empty string. So you return an empty string.
Oh, that is an interesting example that we have here. I mean, I would like to see an example without having the string completely be removed or no string at all.
Exactly.
But there are probably some test cases like that in the code baked into that.
An important thing to watch out for is if the input is only numbers, then you might run into a test case where you've got one number in a string and you try and remove the previous character, but then you would run into an out of bounds error because you're trying to index a -1.
We have a completely distinct approach between Henry's and Gibson's way of doing this. You can see Gibson is doing is a numeric function, but Henry's actually just comparing a string literal of characters.
Yeah.
That is an interesting approach in my opinion. I would do more something like what Gibson is trying to do. But do you have any reasons why Henry is doing a string literal check?
I think it might just be what he's used to, because he has a lot of coding experience behind him.
Fair. I mean, here you have to change it into an integer, where here you don't have to change it because in a string it's just an array of characters. So returning the length of the string minus the index. So taking the numbers, taking the index values and then just giving them one at a time, like just cutting it down slowly. And I think that's what Henry's trying to do until there is no characters left between the numbers and the string.
Maybe. It seems that Gibson is, at the start, has converted his string into a list. Maybe that's what he's more comfortable with.
I mean, something, again, I was talking about, I would be doing something like that.
Yeah.
Because if you give it a list, you can compare the index positions of each. Like, take the first instance of a number and the first instance of a letter, and then compare where they are in the index. And if they are predecessing with each other, then I will remove them. And then
surprisingly, we've got no one trying to run test cases yet. I think Gibson just did, but he's run into some syntax errors.
Oh, classical syntax. These days we have autocompleters and all the AI robots or whatever they're called, and they fix all of this stuff. But when you're in here, hard, cold, no internet allowed, it is a very hard thing to do with syntax these days, you know?
It seems Gibson is trying to use the del function to remove an element from the array. However, that has the consequence of messing up your for loop. So you've got to watch out for that.
Ah, I see. We can look into Henry's work. Right now, he's enumerating through the string with the character and I. And for the character is in a number string, then the index is the class. Find the class if there's no non-digits. Is that a standard library function?
He wrote this function himself at the start.
Oh,
did you notice?
Oh, I did not notice. That was completely fast. I didn't realize that he did that in so fast. Oh, we're getting some prints. We get failed test cases. We've got inputs CB and 3-4, and the printed. Oh, we just heard that there has been a new hint been presented to both of the contestants. Oh, I'm very excited. I think this will give a direction for both Gibson and Henry. Oh, Gibson just completely deleted the whole code base.
Clearly having a massive realization.
Yes, this is going to be either an amazing approach now, or maybe Gibson might be struggling again.
I guess we'll see. Henry trying to run his first test cases, having some issues as well.
We have a comment saying no digit to the left. So Henry has picked up on the nuance of it being the left side, not the right side of the
And you can see he's got 2 del lines, or will, if he's going to delete it all commented out. Interesting. So yeah, he was trying to delete the current index and the previous index. Oh, and Gibson wins!
Won. That is amazing. Yes, Gibson got the hint. Gibson rewired their system and thought of, oh, we got to do a lot like a different approach instead of this approach I'm doing right now. But instead, let's see how they're feeling in Studio 2. Over to you, Zee.
Congratulations, Gibson! You're officially our second semi-finalist, and we will see you next round. Unfortunately, Henry, you haven't made it through to the next round, but there's no way we could let you go home empty-handed. So here is a lovely goodie bag with this year's Coders Cup shirt and mug. Is there anything you'd like to say before you go?
Obviously, congratulations to Gibson, and yeah, best of luck in the semi-finals.
We love to see some healthy competition. This is fabulous. Okay, that's great. Let's check back in with Lukas and Richard. That's done.
That was a really cool game.
This was a cool game, and also it quite matches because you can see in Gibson's match, he cleared all the code, which, given the name of the question, clear digits, it makes so much sense. And so this has been an amazing round. Again, once the hint was presented, Gibson rewired the thought process, which is a very, very important
Yeah,
thing.
it's clear that hint definitely helped him out with solving some sort of the problem.
Yes, but Henry's also thought of something else with using a stack instead of a list. But I think Gibson was just that speedy when it comes to just rewiring and reprocessing the logical sequences.
Yeah, he
to
definitely
solving it.
understood the problem at the end of that.
That was an amazing speed round also, because doing that speed is unhuman in my opinion. I would be struggling and be like, what is going on? I wouldn't understand it at all. But Gibson can doing that is maybe a clear contender to be a finalist.
Yeah, unfortunately for Henry, he didn't seem to get the answer in time.
Right,
so
that's
yeah.
true.
Anyway, let's look at the next matchup.
Yes. And we here have Ash versus Ella.
This will be an interesting one.
Yes, this is the first one we have a C++ programmer.
Indeed, go Ashley.
Oh no, I mean C++ obviously using an inferior language, but that doesn't give them an edge or an advantage. It's just a language in the end of the day. But we can see that we have a computer science student versus a computer science and AI student.
We do. There's also a fairly big difference in language history, programming history.
But
yeah.
It does it give them necessarily an edge? Because this is a tournament about speed.
This is true.
Because without speed, the participants cannot win, especially even getting some test cases out and getting, winning over the fail case, which is, they just won some test cases and the other person did not win any.
Well, let's go meet them now. Over to you, Zee.
I'm here with the last two competitors, Ash and Ella. So Ash, how does it feel to have made it this far?
I'm just really nervous, I guess.
No, it's okay. It's fine to be nervous. You made it this far, so you're definitely doing something right. Taking on Ash is Ella. We hear you've broken the same arm 3 times. How did you manage that?
A lot of accidents. My parents weren't too happy about it.
But you're fully healed, right?
Yes, yeah, this was years ago.
Okay, perfect. Great. If you guys please take your positions behind me, head over to your seats. We're going to begin the final semi-final. Guys, this is the last semi-final. The last round, intense. We kind of carried over. They had hints, but props to the both of them because they made it this far and we'll definitely be seeing Gibson next round. But we'll start this, the final. Nerves are high, but they've got this. It's time for the last quarter-final game, and I'm so excited to see what happens. And so, let's begin in 3, 2, 1, code!
And this is our last quarterfinals game. I'm really excited to see who wins and becomes a semi-finalist.
It is. This is a fun question. Longest palindrome.
Well, as you can see, you're given a string and you have to essentially return the longest palindrome that can be built with those letters. And these letters can be rearranged in any way or any pattern.
A palindrome, if you don't know, is a word that can be reversed and still say the same thing.
Yes, it is indeed, but you know what I say? This is quite a conundrum.
It is, Richard. A good example of a palindrome would be the word race car, because if you reverse the letters, it also says race car.
Does it? I did not know that. That's quite an interesting thing. But let's see how Ashley and Ella are approaching this problem.
They're both really quick going into the code.
we have Ella implementing a stack-dated architecture for each character in the string, and the length of the stack is 0, then appended character onto it.
I think one thing that they've both not realised is that this question asks you to return the max length of a palindrome you can make, not actually make the max palindrome yourself.
Yeah, but
so you could, in theory, which is the optimal solution, count up how many characters of each character you have, and then mathematically calculate what's the maximum possible palindrome you can make.
But then if you also just count up the longest palindrome while you're making it, then you do get the length of the palindrome.
This is true, but it might take longer to do that.
That is true, that is true.
Ashley over here with a triple nested for loop. That is an interesting approach.
Ooh, and triple nested for loop, that is actually crazy. But I don't know if this is the right approach.
I don't know, yeah. Ella over here, only one for loop so far.
Oh, we have an if statement. We have an if statement, and else is a count.
Ashley seems to be doing some sort of... I think Ashley might be brute forcing this approach. With those triple for loops, that's probably enough to get every single possible word you can make, and then check if it's a palindrome or not, and return the maximum palindrome you've calculated.
And this is a quite interesting approach of doing this, but don't you think this complexity is a lot longer than what Ella is trying to do?
Yeah, this is definitely a lot more complex for Ashley. Ella seems to be doing more of what I would do, which is understand the question and just return the maximum you could do. Ooh, Ella trying to run some test cases, but not getting anything.
Oh, not any luck this time, Ella, but maybe next time. You should use the, return true. That works half the time. Not for the integer though.
Yeah, Ashley over here, not running any test cases. Sort of an issue. Or is it compiling? Because Ashley's using C++, of course, yeah. Is he having issues with running the code? Ella trying to get some more test cases, but no, still 0. Still not working.
Oh, as you can see, there's not much going on right now in the code base. I think they're currently thinking and processing. I mean, I would also just, count how many characters.
I mean, Ashley just scrapped his whole code, trying to start from scratch, or maybe not, maybe just reorganizing.
Oh, Ella's passed with 19 test cases.
19, that's a start. Ashley trying to do some as well, but only 0.
I think Ella is now in the cutting edge of victory rather than Ashley. Ashley is less likely to win now because Ella can win by the
Ashley just ahead with 40 test cases.
Oh, I did not expect that. That is an absolute impressive counterback to Ella.
Overtaking.
I think Ash might Ash Ella.
Maybe.
That was funny. I'm sorry. Anyways, let's find out who's gonna be the winner of this round. I think Ashley's more on the edge of winning right now. However, Ella...
The thing is, Ashley is taking a very unique approach, so I'm not sure if that will work to his favour or not. It depends if he fully understands what he's trying to achieve there.
Oh, but I think to take that unique approach, you must understand what you're doing.
Because interestingly, he's got a Boolean to check if it's a palindrome or not, but not if it's a maximum palindrome. So he's not keeping track of the maximum score he could possibly get, and maybe only returning a palindrome, but not the best palindrome.
Okay, so this is not only checking the lengths of the palindromes, but the best length of the palindrome.
Exactly. That is what the question asks for.
Oh, that's such a small little detail that I guess the coders have not seemed to notice. Oh, except Ella. Ella has noticed a max count equals count plus 1.
Ella trying to brute force some test cases with minor changes to the code, but not beating Ashley with 40.
This is not looking good for Ella because Ella has only got 2 out of 62 test cases now, which is significantly worse than what it was before.
Ashley restarting the code? They've just been given a hint.
Oh,
we'll see how this helps them.
This hint is maybe like Gibson's round. It could be a completely revolutionary hint that can just change the code forever.
You might say a game changer.
That is indeed a game changer. And there's going to be more hints given out later on as the round progresses.
Ashley now changing to a single for loop, see if that goes in his favour or not.
We're going for each loop where there's a character for each character in a string.
I think Ashley's actually getting the idea now that you have to calculate how many unique characters you have in your string and then mathematically calculate the maximum palindrome you could make.
And Ella seems to not have deleted any code or rethought of the whole process, but oh, never mind. I spoke too soon. It seemed like Ella has decided to scrap the code base and restart from a fresh new perspective provided by their hint. Now we're starting with an array, though that's not really an array, that is a list.
Yeah, the proper solution for this is realizing that any character with an even count can be fully used for a palindrome. Odd count characters can contribute all of their letters but one, except you can also add one character from an odd count character set into the middle of a palindrome, because that stays the same either way when you flip the word.
Oh, looks like Ashley's back to ground one, back to square one, 0 out of 62 test cases.
Yeah, Ella now sort of ahead with 2 test cases, but that's not much.
Oh, I mean, still 2 is more than 0.
This is true.
Oh, never mind. Ashley's took over again of Ella.
6.
That is an amazing feat that Ashley's doing right now. This is like a tug of war going on between them.
Exactly, very much a tug of war.
Like, Ella is pulling a bit, but Ashley's going back and forth, but Ella is trying to articulate a plan, articulate a thought process.
Less than 5 minutes now, and they've been given another hint.
Oh, another hint drops into the table. Do you know what this means? That this hint will be a stronger hint than the one they were previously provided. Thus, maybe they might solve the question in a lightning speed.
Ella doing something interesting with dictionaries. I think Ashley probably went with a... Ashley's using a map to track how many characters there are, whereas Ella's using a dictionary to count how many individual characters there are.
Oh, because the dictionary's specific nature is that there is only a unique set of characters. Because a dictionary is inherently a set of characters.
Ashley passing 17 test cases now out of 62.
But it was not as good as this 49 test cases that Ashley passed beforehand. But still, Ashley is ahead of Ella right now because Ella has no, gone past the 2 test case barrier.
Yeah, this might be down to the last second.
And here, who is going to be the winner? Okay, my bet is Ashley.
Interesting. Ella is deep in thought though, so maybe she can figure out a final solution.
I mean, she is hitting the thinker pose also. You can kind of see all the thought process, the mathematical equations going through the head.
Absolutely. That hand on the chin is a very strong indicator of a lot of things going up in here.
But also, Ashley just passed 45. This is not looking good for Ella right now.
It is not. But 45 isn't enough? Well, it is now, but Ella could catch up.
Ella could catch up. I mean, now Ella's back to square one again with 0 out of 62. This is not looking good for Ella right now. However, Ashley could have not passed all the test cases. That means this could have been a last, to the last minute.
I mean, less than 3 minutes now. We'll see how it goes.
Well, yes. Oh, Ella's passed 5 test cases out of 62. Better than 2 than last time.
Not good enough though. Not enough to beat Ashley.
No, yeah, they got to get more. They got to get 40 more to beat Ashley in this intense round. This has been a really interesting back and forth between these two characters.
Ashley seems to be catching on that the importance of whether the characters are odd or even, which got him the win.
That is true. I'm on point, on track. That was a very interesting match we had.
That was quite long.
Let's see what Ashley's thinking about this match. Over to you, Zee.
Congratulations, Ash! You're officially our 3rd and final semi-finalist, and we will see you next round. Unfortunately, Ella, you haven't made it through to the next round, but there's no way we would let you go home empty-handed. So here is this lovely goodie bag with this year's Coders Cup mug and shirt. Is there anything you'd like to say before you go?
I should have read the question properly before actually attempting it, but I got that for next time. Maybe next year I'll be back.
Exactly, and we're excited to see you next year. That was a crazy battle. So let's check back in with Lukas and Richard.
That was a really cool match.
I do agree. That was a very, like a tug-of-war kind of style game where Ella got a couple of cases, and then Ashley got a couple of cases, and Ashley got a lot more cases, but then reset back to 0 cases. It was like, you don't know which one, who's going to win what. There was unknown battle.
And that was the first game where you had to get out both test cases.
That is true. And it was actually going...
Sorry, both bonus point.
Hints.
Hints.
Yes.
That's the word.
Now here, we can see that Ella and Ashley, they were going neck to neck, but they were also going to the last minute. And in this case, Ashley would have still won because Ashley already had 45 test cases.
But didn't need to. Ashley got it in the end. Ashley understood the question with what I was saying, knowing if the character count is odd or even, which helped him win.
There you go. And that was the eureka moment that Ashley needed to get all 65 cases.
Exactly. Well, let's have a recap.
So far, what's happened? Okay, in the tournament brackets, we have Ozodbek going directly into the semi-finals, and Jake and Jessie, well, Jake winning that round, promoting to the semi-finals.
Yeah, in the Gibson and Henry round, Gibson won.
And Ash and Ella,
that we just saw, was a very impressive game, but Ash took it for himself.
Thought of it. Ash thought of the question thoroughly and executed it perfectly.
Well, don't forget to follow us on our Instagram at HackSussex and join the community over on our Discord so you can keep up with all the excitement.
This Coders Cup is brought to you by Unity, BCS, Switchplane and the Department of Informatics at the University of Sussex.
BCS, the British Computing Society, is the Chartered Institute for IT. They are the representatives for anyone working in computing. If you aren't familiar with them yet, you should be. After all, they are the ones accrediting our degrees.
And we are excited to have Unity sponsoring this year's HackSussex Coders Cup 2026. With the office here in Brighton, Unity is a global leader in game development, technology, supporting creators worldwide. They are proud to sponsor HackSussex and wish everyone competing today the best of lucks.
We'll hear more about the other sponsors later, but for now, time for a quick break.
We will reconvene in 15 minutes to find out who won away the giveaway.
Indeed. See you all soon.
Bye.
At the University of Sussex, our computer science degrees combine technology with psychology, neuroscience, media, or business. You'll explore not just theory, but also practical applications. Software engineering teaches you to build and manage large projects, setting you up for the kinds of things that you'll do in industry. With our combined informatics and business degrees, you'll learn how to create innovative solutions for commerce, marketing, and management. Learn how to develop games and take advantage of our industry-standard digital media facilities and broadcast studios to produce live shows, visual effects, graphics, and audio. We have strong industry links with the opportunity for an industrial placement year. The university is surrounded by the South Downs with a vibrant, inclusive community.
Sometimes you walk on Library Square and there's the radio or HackSussex or a bake sale or the newspaper's just come out.
You want to feel like you belong somewhere, and that's Sussex.
Search computer science at sussex.ac.uk.
We would describe ourselves as software engineers, but that's only half the story.
We're a business that can help other businesses to become more productive.
I like to think of Switchplane as a tech team for hire.
We've done it before. We bridge the gap between tech and business. You know the business, we know the tech, and we know how to implement it.
So a lot of businesses will be in this position where they're firefighting, they're really busy, and they never seem to be able to find a way to take that kind of strategic leap forward.
So those clients that want to grow, they're stuck, they've got systems getting in the way. We build custom software to help them get out of those holes that they're in.
We have worked with construction firms, we've worked with insurance companies, travel companies, anything really. And a similar sort of issues come up.
We will go in with a consultancy-led approach and work with them. They know their business, we know the technology, and we work together to solve the problem.
So we'll try and understand what the business does, the problems it tries to solve, any pain points that the business has, and we're able to sort of figure out what are the first steps we take.
I like working with these clients. I like going out and meeting them, seeing how their business operates. And because I've got a love for tech and software, there's so many opportunities for me to think, that could be sorted, that could be improved. And I love that.
We work in 2-week sprints with our clients. We help identify this core problem and we just go at it every 2 weeks and try and break it down into its next most valuable thing.
We're taking small steps to solving big problems that customers have.
It takes the risk out of software development, so ultimately the customer gets what they want, even if they didn't know what they wanted in the first place.
By studying computer science at the University of Sussex, you'll learn how to develop robust computer software and systems for the future. Studying AI, you'll learn how we model intelligence with computers and how we can embed artificial intelligence in practical solutions with robotics and adaptive systems. We're bringing together the theory of AI with physical hardware, allowing you to build and learn with robots in the real world.
You come in, you work in the labs with everyone.
I do like hanging out in the labs.
Like, you're kind of even on your weekends coming in because you just enjoy being here, doing work with your friends.
Whether you're an undergraduate or looking for a postgraduate opportunity, such as our MSc in Advanced AI starting in January 2027, there's no better time to study computer science at Sussex.
I would say my favorite thing about Sussex is that you can always go outside and feel like you're in the middle of the forest.
And also Brighton, of course.
Search computer science at sussex.ac.uk.
Welcome back to the HackSussex Coders Cup 2026.
The first giveaway is now closed. Congrats to Geordie Bazalga for winning a voucher. DM us on Instagram after the show to get your prize.
And so the quarterfinals are 100% complete with all their achievements.
A big well done to Jessie and Henry for demonstrating you're one of the top 7 programmers at Sussex. As we've had an absence, we've had to bring back Ella, who passed the most test cases out of all of the losing contestants. So she's going through to the semi-finals.
This leaves our 4-bit semi-finalists Ash, Gibson, Jake and Ella.
The winners of this round will be walking home with a 3D printer.
No way, that's so cool. I've always been so fascinated at how many things you can make with them, like a cactus chessboard.
Oh yeah? Awesome minifigures, plant pots, phone stands, replacement parts, new bits and bobs.
Hold your horses, Lukas. I get you enthused them on the versatility of a 3D printer, but the show must go on.
Sorry, Richard. Let the semi-finals begin.
For the first round of the semi-finals is Ella versus Jake.
This will be a fun matchup. Ella, coming back from the dead.
And you can see this is going to be an equal matchup, I believe so, because Ella has proven to show good logical thinking and starting to, figure out piece by piece.
Exactly.
But Jake is really fast.
Jake was really quick in that first round.
That was true. So I don't know if Ella can beat Jake in the sense of speed, which is what this tournament is all about. But if the question is really hard, then Ella might have the edge on this.
I guess we'll see.
Yes,
Let's go back over to Zee to see how our competitors are feeling.
I'm here with the first two semi-finalists, Ella and Jake. So Ella, how does it feel to have made it this far after just losing? You're back again.
I didn't think I'd be here about 5 minutes ago, but I guess next year can wait and I can go to the finals this year.
It's time to officially avenge yourself. And up against Ella is Jake. How do you feel after winning your round? Did you think you'd make it this far?
I'm pretty happy I got this far. I'm hoping I'll win this one again.
Exactly that. Good luck to the both of you. If you both take your positions behind me, let's begin our first semi-final round. They both seem perfectly matched. I think the skill set is definitely very leveled. We're gonna see who wins our first semi-final. Nerves are rising, tensions are high, and we know they'll both do well regardless. They've made it this far, so they can definitely code a bit, or somewhat, let's say. But it's time for the first semi-final, and I can't wait to see who gets through to the finals. And so, let's begin in 3, 2, 1, code.
And it's the first game of the semi-finals.
Oh, I'm very excited for this. And this is one of my favorite questions, actually. The minimum twin of a sum of a linked list.
Maximum twin, actually.
You got me there, red-handed. Well, you see, you take the first element and the last element, and you basically compare them to the next two elements in the list. So it goes like this and going down the list to the middle. This is given a even number of lists, so we don't get those pesky odd numbers sneaking in there.
Ella jumping ahead, passing 4 out of 63 test cases already with a quick return 7.
Oh, that's already starting off strong for Ella, but you can see Jake's methods are different. Instead of running straight away, Jake thinks about it. Thinks about the process.
You say that. Jake's got a lot more code than Ella does. Ella seems to be thinking deeply about the question.
Ella returned 7 and got 4 of the test cases.
Yeah, but Jake seems to be running ahead with that code.
It seems like this is quite a simple task. If you think about it, if you take the first, this is the first element of the list, and the second element of the list, and then the third element. If you just use the index of it, right?
Well, you would think it's that simple, but we're actually here, you're given a linked list, not a regular list. So you can't just index the values.
I did not notice that it was a linked list. Now that is quite the problem, isn't it?
Well, an easy way to get around this would just be to iterate through the linked list and convert it to a regular list, and then you can index everything like usual.
I mean, in that case, you can probably do that, and that's probably the easier way out, but there's probably more of an elegant solution to this problem.
And it seems that Jake is, well, doing potentially not what I said, and getting the head and, so the first and last element of the linked list, and then sort of iterating inwards towards the center so we can match the first and last numbers.
It's kind of similar on how I would have also approached it, but instead of just checking those, I would have just popped them instantly.
Yeah.
When you pop them, you can just get the O1 of complexity for both ends of the linked list.
Well, we can see Jake trying his solution.
Oh,
and it works! First time!
And Jake absolutely smashed through in the semi-finals.
That was really impressive, Jake, with the one-shot code there.
No, yes, I mean, Jake has been one-shotting all the codes recently, and that is an actual amazing thing. And Jake is a legend when it comes to just thought process, execution, and then one press, and bam, all the test cases done.
Unfortunately for Ella, losing twice is not a great feeling.
No, it is not, but Ella did make it through the semi-finals, which is quite an impressive feat, nonetheless.
Well, let's go see how they're feeling. Over to you, Zee.
Wow, congratulations, Jake! You're our first official finalist, and we will see you next round. Unfortunately, Ella, you haven't made it through this round, but not only have you won this lovely bag from before, with this year's Coders Cup shirt and mug, we'll also be seeing you after this round again to see who will take the official 3rd place. What do you have to say about that?
2 losses in one day is not the best, but the speed that you executed that is insane. I didn't even understand the question at the... So yeah.
Honestly, all of our heads spun in this studio, that's for sure. But we will see you next time, Jake. Thanks, and let's get back in with Lukas and Richard. That was really good, I'm not gonna lie.
So that semi-finals game revealed our first finalist.
It has.
And so that it would be Jake.
It will.
But this does mean Ella goes to the 3rd place round.
She does, so she gets another attempt at her glory.
But let's look into the game more specifically. You can see Jake already going through the code and making sure everything is written at one go, and then executing it, but not passing all the test cases, which I think made Jake kind of confused. Ella tried an early sneaky return 7 at the start, but of course we've already seen that trick way beforehand. So we only returned 4 passes.
It was quite impressive that Jake managed to get his linked list process working that quickly.
I mean, as I was explaining, getting the both ends of the list is probably the fastest way to solve this.
I mean, once you've got that, you can just iterate inwards and then you're done if you're keeping track of the maximum.
Yeah, because the one list links after another. But if this was only a directed linked list, if it was a directed linked list, this would not work.
Well, let's see who's up next.
It's for the 2nd round of the semi-finals. It's Ash versus Gibson.
This will be fun.
Oh yes, it will be. I mean, Ash showed some immense display of skill.
I mean, Gibson with 67 years experience, that's quite impressive.
I mean, that is an amazing amount of years of experience. I haven't even been alive for that long. But in the end of the day...
And Ashley, again, C++ for the win. We'll see if it wins again.
Hold your horses again. C++ is definitely the worst language compared to Python.
I don't know, Richard. You can do some pretty cool things with it.
But we can debate all about this again and again. But let's go over to Zee and see how our 2 competitors are doing.
Absolutely.
And I'm here with our 2nd pair of semi-finalists, Gibson and Ash. How are you feeling, Ash?
I'm feeling a bit better about it this time, now that I've actually solved one of the questions. I have a more of idea of what to expect. So
Definitely, you're a bit more warmed up now, you know, you've done this before. And taking on Ash is Gibson. Did you think you'd make it this far?
Yes. Yeah, I think I thought I would. I've done lots of leak codes. All I think about is leak code. When I sleep, I dream of leak code. When I eat, I think of leak code. When I'm on my computer, I do leak code. So I'm gonna win.
We love the confidence. Eat, sleep, drink, coding, leak code. We love it all. That's great stuff, guys. If you take your positions behind me, we're going to start our last final semi-final. If you just head on over. Wonderful. Guys, we love the confidence. Gibson, eat, sleep, and drink, leak code, coding. I need to be like him because I do computer science and that's definitely not me. Ash warmed up, did well in his round. They're ready to go. This is going to be an exciting round. Tensions are rising. This is the last semi-final and we are going to find out who is going to go to the finals of the Coders Cup 2026. It's time. So let's find out who will be facing off Jake in the final round. 3, 2, 1, code!
This is the second semi-final game of the Coders Cup 2026.
It is, and it's an interesting question. So, for this one, you've got, it's called Projection Area of 3D Shapes, which is quite the mouthful and the description is quite long. So basically, the problem for this is you have a 3D grid that is populated with towers of cubes. The objective is to calculate the total area of the tower's shadow when looked at the top, the front, and the side perspective.
All three perspectives, you got to be three-dimensional about this.
Exactly.
Well, in this case, I would approach it in a sense of, okay, I'll count off all the shadows from the top. I mean, if there's more than two, then they will produce a shadow. But if it's just one, the likelihood of a shadow is less. Do you believe so?
Well, so how this works is you're given a 2D array where the I and j indices represent the x and y coordinates of that block. Then the value of that represents the height. If the height is 0, then, well, there's no block, so there's no shadow. But if it's 1 or above, then there's a block there, so there will be a shadow.
So it would be probably based on the y values, so, and not the x values. But not necessarily. It's if there's more x values, then it can be wide and then tall. That would be a 2 by 2.
Yeah.
Of the shadows.
So, interestingly, the easiest way to go about this, at least for the top face, is iterating through the whole 2D array, and then if a value is 0, or you don't add that up, but anything else than 0, then that will be a 1 by 1 block for the top-down view. So you add all of those up, and you've got the surface area for the top view. It gets a bit more difficult to the front and side view, because you've got to do some math to work out the maximum height of each element you're looking at. It seems that Ash is steaming ahead with a nested for loop, clearly looking at the x and y positions of the 2D input he's got.
And this does show that C++ is a quite strong language, but I believe in Gibson as a true Python user. Gibson will understand and will complete this question and smash through Ash.
Well, we'll see. Gibson seems to be pretty stumped there with that facial expression.
I believe after this question, someone will be projected outside of the tournament.
Guess we'll find out. Gibson has tried his honest code, but he's got some errors there, so we'll see what happens with that.
Oh, good old errors. Oh, it's an index out of bounds error?
Ash seems to be importing some extra libraries to handle bit manipulation. I wonder how that will work.
Straight up bit manipulation. That is a straight up hardware level control. This is the great strength about C.
It is.
It is this versatility on the kernel itself.
Very good for low-level control. For example, like robotics, which I like myself quite a bit.
Well, obviously that's great for the speed of the code and the compilation time, but not necessarily speed of the actual typing up the code.
This is true. Python does have that benefit of you can get down some very complex processes very quickly.
And that's what you need for this programming. That's what you need for this, Coders Cup. That's why speed is king in this competition.
Gibson's still thinking after over 3 minutes. Clearly having a bit of a think there.
Oh, we're stepping into the world of vectors. I have not seen a vector in a long time. And a vector is just an array, am I right?
I mean, yeah, it is just an array, a fancy array.
That's fair. And Gibson is still trying to map out a minimum?
Well, I think he's just doing a lot of thinking. I think now maybe he has a proper solution he's going to try and go for. I guess we'll find out.
I mean, Ash is already starting with the double for loop.
Yeah. Interestingly, so what does he seem to be doing in Ash's code? He's got a total and a max height variable that he's updating as he iterates through the grid.
I was also thinking about that, because if you go to the for loop, you're going through 1, 2, 3 like that, and then go up like that, making the grid itself.
Although I'm not sure that max height value will be much use to him, because it's only calculating the highest tower there is, not the maximum height of each tower per perspective, which is what he needs.
Oh, that is a very, very small thing to consider, but a major, major to the code itself and the structural integrity of it.
Absolutely. The algorithm matters, and if it doesn't work, well, you won't pass the test cases, which is what you need to do.
That is true, only to be the finalist of the Coders Cup 2026. I wonder who's going to pass in this. And
Gibson, using some Python shortcuts, the sum command, instead of where, in Ash's case, he'd probably have to write his own for loop and function for that.
I mean, we can have a quick look at the examples that are provided here.
Yeah.
We get an input grid of 1, 2, 3, and 4.
So
and the
in that
output
case,
is 17.
yeah.
Why would that be?
In that case, so input grid, the index to access the 1 would be 0, 0. So at coordinate x, y, 0, you would have a block of height 1. We've just heard they've been given a hint. So maybe that will help either of them figure out what they're doing.
Yes, I mean, this is a very complex question, and especially when you're under time pressure and time constraints and all of that, this is going to be a very, very more difficult question. It will just exponentially increase the difficulty of this question.
Yeah. Maybe let's go through example 2, because that seems to be a bit simpler to explain, because there's only one value in there. So at index 0, 0, you've got a value of 2. So at x, y position 0, you've got a block, a 1x1 block, that is 2 units tall. So then from the top perspective, you've got a 1x1 area. From the side perspective, you've got a 2x1 area, so an area of 2 meters squared, or whatever unit it is. Then the other side, you've got another 2 meters squared, so 2 plus 2 plus 1 equals 5, which is the output you need for that.
So the grid is not made from the actual values of the array, but the indexes of the array.
Exactly. Which is, it can be quite confusing when you read it the first time.
Oh, that's going to be quite a hard one to figure out. I mean, here we have Ash going with a size of the height and the max height again.
He seems to, yeah, a lot of loops in Ash's code, and he's got quite a lot of long code, which I guess is typical for C++.
So is he just pushing back the blocks into a separate vector?
Potentially.
This is interesting. Oh, I see what he's trying to do. He's trying to get a push on perspective 2 and 3. But before that, let's look at Gibson.
Gibson just passed half of the test cases.
I know.
That's quite impressive.
I'm very excited.
Yeah.
Gibson does look like ahead, and that was, of course, proving that Python is particularly the better language.
If Ash doesn't keep up or catch up, then Gibson will be taking the win after the time runs out.
That is true, but also Ash might have the victory by just doing it all in one run.
Yeah, 5 minutes remaining, and they're getting another hint.
Oh,
we'll see if that can help them.
This hint is gonna change everything, or I believe so.
Well, let's see.
I mean, in the Ash case, it looks like Ash is doing a lot of pushbacks on different perspectives. So I believe that the perspective 1 is the highest, so he doesn't make a new vector for that, and just checks it from a bird's eye view. But for perspective 2 and 3, Ash uses mathematics to calculate what is the shadow casted over by these perspectives.
I mean, in Python, if you know your list comprehension, if you're trying to use list comprehension in Python and you know how to use it, you can solve this question in like less than 10 lines of code, which is pretty impressive.
But this is quite a lot of code and a lot of thought processes for first years. These are 2 first years of Sussex University. That's a very, very impressive feat to be here at the Coders Cup.
Yeah, they clearly have a lot of prior knowledge and interest in computer science.
That
is perfect for this degree.
Well, of course, for the computer science degree, it is perfect.
Well, of course, we should mention it's not necessary for you to have coding background to start a comp sci degree. But in this case, in a competition, it is pretty useful.
Nor is necessary to code with a comp sci degree, like we saw with Jessie, who coded with a physics degree.
Well, in physics there is a bit of coding to it as well, but of course, you learn like other things, like gravity.
That's more MATLAB and levels of like graphs rather than actual logical algorithms.
Yeah. Ash running into some issues there with compilation. Seems he's got some issues with some functions, expecting 3 arguments instead of 2.
Oh. That's an interesting, well, I guess that's the argument error.
Yeah.
If Ash just figures out what arguments to pass through, then maybe Ash could take it all in one sweep.
Gibson doing some debugging, printing out a bunch of values to see what happens. We'll see if that gives him any help.
I mean, for the value in the grid, Gibson just adds the length and the maximum of the values.
Yeah. Ash did seem to be onto something, but he just deleted his whole code. Oh, and he put it back.
And yes, he basically said, I'm going to rethink about it. And then I'm going to be like, actually, no, this does work. I just need to really focus on what arguments I need.
I mean, only 2 minutes left.
I mean, I understand Ash's perspective from it, if you get what I mean, because Ash is looking at different perspectives of the block itself.
Exactly, Richard. That's the hard part of it.
That is true, that is true. I mean, we're approaching about 2 minutes of the game, and this is going to be where it gets intense between these two contestants.
It might come down to just the number of test cases between them.
Oh, I hope someone wins before that then, because that can show their true essence of their skill. But still, it still already shows how much skillful they are.
I have noticed with the people who have been using C++, like Ash in this case, it takes a whole 3 seconds to compile their code before they can run it, which in the case of Python where you can run it straight away, that might give Gibson a bit of a lead.
Well, isn't that quite backwards, because Python is known as for the slower language than C?
It is slower, but you don't need to compile Python. That's the benefit of it.
Ah, yes, because it's an interpreted language.
Exactly.
That makes a lot more sense now, obviously. Here, Gibson is doing a for loop, and another for loop. You can see that he's getting the grid size and then going through each index of that grid, and then checking for the height in that grid where a block occurs, that is a height of that grid shape, and then checking again if the height is less than the k value, which I'm presuming is 0, if I'm presuming right.
Yeah. So if the block is 0, then it doesn't have any shadow because it doesn't exist.
Yes. Yeah. We're starting off with 0. If 0 is less than the height, then of course there's no block there. But if it's more than that, then the loop continues on and it gets added on to a perspective.
Only 30 seconds left. Let's see what happens.
Oh, this is the last 30 seconds.
The pressure is building. Gibson seems to be struggling here, sort of just staring at the question, trying to get something out there.
I think Gibson is just missing one key information to solve the code, because I understand Gibson's way of approaching this.
I think Gibson was ahead, wasn't he, on the test cases?
Yes, it was.
Yeah, 10 seconds left.
But again, Gibson's approach was the different perspective functions, which is, sorry, Ash's was the different perspective approach, but Gibson wasn't like that.
Gibson wins.
I know. I mean, it was a very good approach with the multiple perspectives, and that is what gave Gibson the lead.
Clearly a very difficult question to think about during that tight time frame.
I completely agree. Even without a tight time frame, it is a very difficult question. But let's see what Gibson thinks about this. Over to you, Zee.
Congratulations, Gibson! You're officially our second finalist, and we will see you next round to take on Jake, who you will be versing in the final round for the crown. Unfortunately, Ash, you haven't made it through to the next round, but not only have you won this lovely bag with this year's Coders Cup shirt and mug, we'll also be seeing you soon after this round again to see if you can fight for that 3rd place. So not all hope is lost, don't worry. Now, let's check back in with Lukas and Richard.
That was a very, very tough semi-final round.
That was the first time we had to go down to test cases.
I do agree with that, in that sense that the projection question is a quite hard question to visualize in your head also, with the different block heights, and you have to consider that the index of the array itself is the grid rather than the values in the array, because the values in the array is the block values instead, and you have to count of, if there's a minimum of 0, then you should consider that block itself, the minimum of the x value being 0, oh sorry, my bad, the y value being 0, and that itself is a major thought process.
Ash was clearly in the right mindset with all his for loops in the C++ code, but clearly he just didn't get it in time, and that's what it's down to in this competition, it's time.
I mean, I do agree with Ash's way of doing it with a quick checking on the for loops on the Python check of okay, let's check if all the grids are there and then check where the blocks are. But that's not necessarily helpful for this question itself, because the location of the block doesn't really matter. It's how much shadows they cast is what matters. I mean, if the shadow is overlapping, would you count it as 1 or 2?
Well, 1, because the shadow, it doesn't matter how strong the shadow is, how many blocks are in the way, it just matters the area of the shadow. So if there isn't even as just one block blocking that perspective, then that counts as a shadow.
But that gives this question a lot more complexity, because you have to also consider the associative nearby blocks taking over the shadow. If there's a shadow in between 2 blocks, you can only count one of those blocks, and the other blocks you have to cancel out that shadow, which is a quite complex thing.
We've got some very interesting questions coming up in the next rounds, which we are very excited to see.
I do agree with that, but this set of questions will decide.
Yeah.
These set of questions will decide who will be the final champion of the Coders Cup 2026.
And a champion of the Coders Cup 2026 gets this beautiful trophy.
Oh, that is true. Though I would love to drink of that trophy myself. Yeah. I mean, please.
Oh, so let's see who's up next in the third place matchup.
Oh, the third place matchup.
So next up, the third place match, which is where the defeated competitors from the last 2 games get to scrap it out for a place on the podium.
In this case, we have Ella and Ashley going against each other. Again, Ashley did a really good job in the last round against Gibson, and Ella has proven to be a strong competitor also.
Again, Python versus C++, so we'll see who wins.
And the winner of this round will win a copy of the 1995 film Hackers, starring John Lee Miller and my favourite, Angelina Jolie.
Enough of your fanfaring, Richard. The match for third place is about to begin, so over to you, Zee.
Did I cover the mic?
We're here for our classic third place round, which of course comes with a copy of the 1995 film Hackers for the winner. So, Ella, how do you feel about that?
To be honest, I hope I don't lose. 3 losses in one day wouldn't be very nice, and I might have to retire. Shout out Student Finance.
It's fine, we believe in you. And how do you feel about that, Ash, potentially winning the classic Johnny Lee Miller and Angelina Jolie film?
I'm not really bothered, to be honest.
No, it's okay. Welcome back, Ash. How do you feel after that round? It was quite intense.
Disappointed, but Gibson does deserve to win. So, yeah, I just think he's very good at coding, so he definitely deserved it.
We love that healthy competition. You did very well. That was very intense. The countdown literally reached the end, so all props to you. But let's see who can win this round and take home that movie. That will be a great watch after the Coders Cup. So please take your seats ready for the third place competition. Guys, the third place competition to see who's going to take home the Hackers movie. I've never watched that, so I wonder how that's going to be. Maybe they'll let me borrow it after they're done. But that was also a really intense round. Gibson thankfully won with his most test cases, and Ash is now fighting it out for that third place. Tension is definitely rising because they both really want that movie. So let's hope that whoever wins enjoys that after this. So, time to see who's leaving with the Hackers movie and who gets hacked instead. In 3, 2, 1, code!
And so, we've got the third place match now.
Oh, for my favourite prize also. And this question is, well, water bottles. You're given a number of full bottles and you have to drink them all. Cheers to that. And then you can exchange every empty bottle for a full new one. How many times can you drink and drink totally?
Yeah, so this is, you've sort of got 2 key approaches for this question. You can either run through the process. So let's say you start with 9 water bottles and it costs 3 empty water bottles to get a brand new single full water bottle. So you drink all the 9 water bottles, and so you've drunk 9. Then you exchange 3 into 1, so that 9 empty bottles becomes 3 full bottles. Then you drink 3 more, so you've got 12. Then you've got 3 left, which you can exchange to 1 final bottle, drink that, and you've got 13 bottles that you've drunk in total.
I'm liking the way that Ella is thinking about this, which is the modular approach, where you take the empty bottles, modular it with how many you can exchange for, the X factor, and then +1 obviously because you get another bottle itself. But this seems to not work for Ella. However, for Gibson,
he's passed 38 test cases.
Yes. For Ash, it's a total of number of bottles. The total is Ash is just adding on the total of bottles.
Might have another tug of war match here. Ash with 38, Ella catching up with 6, but not enough just yet to overtake.
This is actually kind of interesting because every iteration Ash adds on, Ash also takes the new bottles by dividing the number of exchanges.
That is what you're meant to do, but it can happen that you don't have a perfect exchange rate. So what do you do in that case? Well, you've got some leftover empty bottles that you can't refill or exchange, so you've got to just leave them be.
Well, you got a reminder. So modular does produce a R value, which can be used, aka the remainder of the bottles. And in case of Ella, I like the mathematical way of approaching this, but it's not quite there yet because
clearly in some deep thought, Ella, on the table there.
Yes, because this is more of a number of list of bottles that could be an approach. I mean, Ash already started with a strong lead, but Ella is struggling. But if Ella gets the maths right in one go, I think Ella can sweep the third place prize.
Ash, interestingly going with a while loop. That could have some consequences if he doesn't handle the cases properly. Because what if you just have some remaining empty bottles and you'll be looping forever and you'll never get the test cases done?
In that case, you just have a break function in there, where if the modular of the exchange is not 0, then it will break.
Well, you would, but he doesn't, so we'll see what happens.
Oh, that is true.
Ella ahead, again, jumping only a few more test cases, 13 ahead of the 5 previous she had.
Well, as I was mentioning, you see Ash is already starting with the reminder variable by saying the number of bottles is added by the reminder. So Ash is thinking about the reminder values and also might consider the full-on repeating loop, especially when it comes to dangerous
It looks like that is what he was trying to do. We'll see if it pans out in this compilation.
I see. I'm really excited for this. Ella has just struck 13 more test cases, totaling to 13 more test cases, but there's still 57 more to complete.
And Ash takes it.
Ash absolutely ashed Ella. That was a legendary battle. I mean, the number of bottles, drinking a lot of water bottles, that was crazy. But let's see.
That was a lot of water drinking.
Let's see what Ash is thinking about drinking water. Over to you, Zee.
Congratulations, Ash! You have won what I think we can all agree is the real prize of tonight. A copy of the 1995 film Hackett's starring Johnny Lee Miller and Angelina Jolie on Blu-ray. Are you looking forward to watching that?
I'll have to get a Blu-ray player first, but yeah.
No, that was honestly a comeback. How do you feel after that?
I feel pretty good about it. It was a fairly easy question, but I'm happy that I managed it in the end.
That's good. But unfortunately, Ella, you didn't come so close, but didn't quite get to take home the coveted movie Hackers on Blu-ray. But you're not going home with nothing either. Both of you are going home with the HackSussex bag that has the shirt and the mug and also an Atari games console each. Now, Ash, before we send you on your way, is there anything you'd like to say to the people at home?
I love you, Mom. She's watching, I think. And good luck to Jake and Gibson.
Honestly, great sportsmanship. We love it. And what about you, Ella? Anything to tell the adoring fans at home?
practice leak code, and if there's any recruiters watching, this is not an accurate representation of my leak coding abilities. I know I lost 3 today, but I promise I am good.
No, we love that. We all need to take your advice and practice that leak code. So, what a great round. Let's check back in with Lukas and Richard.
So Lukas, let's have a recap. On the screen we have a quick tournament brackets of Ella and Jake in the semi-finals.
Yeah, so starting off we had Jake versus Jessie, where Jake took the lead. Then
going into the semi-finals with Ella.
Gibson versus Henry, where Gibson won.
And
then Ash and Ella,
yep,
where Ash won.
Yep.
And when it came down to Gibson and Ash.
And now it's going to be the finalists. The final round, and this will be the person who will be crowned the king of all coding in Sussex.
Jake versus Gibson.
That is true.
See.
Who is the true victor
of
the Coders Cup 2026?
With the finals approaching, we would like to take a moment once again to thank our incredible sponsors, Unity, BCS Switchplane, and the Department of Informatics at the University of Sussex.
Switchplane are software engineers that develop custom software and AI solutions using modern cutting-edge techniques. They do great work supporting the local tech community, being the driving team behind Chalk Eastbourne, allowing local tech enthusiasts to network monthly at their local meetups.
And of course, a huge thank you to the Department of Informatics at Sussex. They regularly sponsor events like this and are incredibly supportive of the students here. If you're looking to study a computer science, AI or digital media degree, Sussex is the place to do it.
And don't forget to follow us on our socials at HackSussex and join the community over our Discord. Alright, time for a quick break and a munch.
We're taking a break, but stay tuned. The finals are looming and you wouldn't want to miss out who is the best programmer at Sussex and the Coders Cup 2026 champion. See you soon.
Bye.
At the University of Sussex, our computer science degrees combine technology with psychology, neuroscience, media, or business. You'll explore not just theory, but also practical applications. Software engineering teaches you to build and manage large projects, setting you up for the kinds of things that you'll do in industry. With our combined informatics and business degrees, you'll learn how to create innovative solutions for commerce, marketing, and management. Learn how to develop games and take advantage of our industry-standard digital media facilities and broadcast studios to produce live shows, visual effects, graphics, and audio. We have strong industry links with the opportunity for an industrial placement year. The university is surrounded by the South Downs with a vibrant, inclusive community.
Sometimes you walk on Library Square and there's the radio or HackSussex or a bake sale or the newspaper's just come out.
You want to feel like you belong somewhere, and that's Sussex.
Search computer science at sussex.ac.uk.
We would describe ourselves as software engineers, but that's only half the story.
We're a business that can help other businesses to become more productive.
I like to think of Switchplane as a tech team for hire.
We've done it before. We bridge the gap between tech and business. You know the business, we know the tech, we know how to implement it.
So a lot of businesses will be in this position where they're firefighting, they're really busy, and they never seem to be able to find a way to take that kind of strategic leap forward.
So those clients that want to grow, they're stuck, they've got systems getting in the way. We build custom software to help them get out of those holes that they're in.
We have worked with construction firms, we've worked with insurance companies, travel companies, anything really. And a similar sort of issues come up.
We will go in with a consultancy-led approach and work with them. They know their business, we know the technology, and we work together to solve the problem.
So we'll try and understand what the business does, the problems it tries to solve, any pain points that the business has, and we're able to sort of figure out what are the first steps we take.
I like working with these clients. I like going out and meeting them, seeing how their business operates. And because I've got love for tech and software, there's so many opportunities for me to think, that could be sorted, that could be improved. and I love that.
We work in 2-week sprints with our clients. We help identify this core problem and we just go at it every 2 weeks and try and break it down into its next most valuable thing.
We're taking small steps to solving big problems that customers have.
It takes the risk out of software development, so ultimately the customer gets what they want, even if they didn't know what they wanted in the first place.
By studying computer science at the University of Sussex, you'll learn how to develop robust computer software and systems for the future. Studying AI, you'll learn how we model intelligence with computers and how we can embed artificial intelligence in practical solutions with robotics and adaptive systems. We're bringing together the theory of AI with physical hardware, allowing you to build and learn with robots in the real world.
You come in, you work in the labs with everyone.
I do like hanging out in the labs.
Like, you're kind of even on your weekends coming in because you just enjoy being here, doing work with your friends.
Whether you're an undergraduate or looking for a postgraduate opportunity such as our MSc in Advanced AI starting in January 2027, there's no better time to study computer science at Sussex.
I would say my favorite thing about Sussex is that you can always go outside and feel like you're in the middle of the forest.
And also Brighton, of course.
Search computer science at sussex.ac.uk.
Welcome back to the Coders Cup 2026. We have another giveaway for you guys at home. All you need to do is head to the live stream chat and tell us who do you think will win our finals and be named the best programmer at Sussex.
Good luck. Let's recap what's happened so far.
Yes. Let's see our brackets. You see, now we have done Jake and Jessie. And Gibson and Henry and Ash and Ella, and they respectively go to their semi-finals.
We had Ella and Jake, which was very interesting. Gibson and Ash.
That was very difficult.
Yeah.
So that was an interesting round and a very difficult round.
Then we had the third place round, Ella and Ash. Unfortunately for Ella lost all her games so far.
Although Ella's approach to the third place round was my favorite approach in the game so far, because of the one-line mathematical approach of solving it, which was a very intuitive and a creative way of doing it.
Anyways, we are almost there, folks. we have narrowed down our 8 contestants to just 2 finalists, and it's finally time for the grand finale.
Oh, and it would be Jake and Gibson. But they have one more challenge ahead of them.
The title of the best coder at Sussex does not come easy.
Oh, we do not have 1, not 2, but 5 questions for our coders to answer.
Yes, that's right. 5 questions, and our contestants will have up to 30 minutes to answer as many of them as possible.
Both contestants will work on the same questions, and when one coder completes it, they snatch it away for themselves and move on to the next one.
This means whoever can get 3 questions completed the fastest will take the crown.
Ah, Lucas, there's more than just the title to be won here.
But what could be better than years' worth of smugness and bragging rights?
Well, you see, nothing, but a brand new drone does come pretty close, doesn't it?
Oh, that's pretty cool.
All right then, let's head over to Zee and how our finalists are feeling.
After making it through the weeks of online qualifiers, then coming here today and fighting your way through to the quarterfinals and semi-finals, knocking out everyone in your path, you have made it to the live final. Congratulations to the both of you again. How does it feel to have made it this far?
Yeah, it feels pretty good, and hopefully I'll win.
Wonderful. We need that confidence. And Gibson, what about you? How do you feel?
Great. It's just like my dream last night when I was dreaming about doing this. And I also solved a bunch of leak codes alongside it. So, yeah, it's pretty good.
We love that. You need to dream that you've already won so you can envision it when you're sat. So, for the final time today, if you guys take your seats next to me, this is going to be an intense battle. They seem greatly matched. Both have been learning their leak codes, going over their DSA. We all need to make sure we're like them for this end of year prep. But it looks like it's going to be an intense competition. They're going to have 5 questions different from our other round, so it's going to be intense. The tension is rising. It's boiling in here, in fact. It's so high. Now, it's time for us to decide who is going to be the best coder at Sussex once and for all. Who will it be? Who do you guys think is going to be? I hope everyone is ready. Let's find out in 3, 2, 1, code!
This is the final round of our Coders Cup 2026, and this will decide who will be the best program in Sussex.
Yes, it will. And these questions for this game are interesting. You've got 5 questions in total, and the goal is for one person to get 3 the quickest.
Well, you can see something here very important. This is a white or black question.
It is.
A minimum recolors to get reconstructive of the black blocks. So you're given a string and you're given a number and you're given a k value, a target value, and you're trying to find out how many consecutive black block boxes come in that string. For example, if you're given a 0, 1, and 2.
I think that example might be wrong. For this question, you've got, so you want to calculate the minimum recolors to get k consecutive black blocks. But, so you're given either, I believe, yes, a string of either W or B. So you've got a string that's made up of W's or B's, and your goal is to try and find k consecutive, so you're given a value k, in order to find an area in that where the minimum, where you have to recolor the minimum number of white blocks to black to make that k length of black blocks.
That is true. I mean, it's all about, you can't look at this problem in a black and white view. You have to, look at it in a more of a diverse view.
Exactly. There's a lot of different ways to solve this question.
I would take the first biggest consecutive blocks and then keep it as the maximum. And then afterwards, I'll look for a bigger consecutive blocks. If I can't find it, then the maximum is the best one.
Yeah, you're on the right track there, Richard. So the ideal solution for this is actually a sliding window approach. So you have a sliding window across your whole blocks array of the length k, and you find out what area in that block has the minimum number of white blocks that you would have to replace. Okay. And then that's your answer. That's the minimum number you have to replace, and also your turn.
I see. Right, because it's not only asking for what's the most consecutive, but it's about what's the most consecutive we can replace to make a bigger consecutive.
Exactly.
So in that case, I will look for the first big consecutive number, and then the next 3 I will replace it with the black boxes.
Jake here already running his code, seeing what happens. Can't see the test cases yet, but it looks like stuff is happening.
And Gibson is also currently thinking about the question, as always.
They both seem to have similar approaches, using some for loops.
And there's a difference of infinity, and for the range in I in the cave blocks, and the length of the string, of the length of the block. So however long the block is, each block it is, each specific block.
Jake here with 24 test cases passed, 14 now.
Oh.
That's a start, that's beating Gibson.
That jumped from 24 to 14 quite quickly.
It did.
And that's pretty fun.
But again, it doesn't take just one win to win the finals, it takes a whole 3 games.
Oh, and we know Jake is a programmer because Jake just had the missing brackets syntax error. Every programmer experiences that specific syntax error. Is the most common one.
Absolutely.
Gibson
here also trying to run his code, but having to do some debugging.
Well, very much so. I mean, this looks like the traceback error. I can't really see what the error itself is from the terminal, but from what I have to specifically read from, it might be a range error. So might be the length of blocks -1, because Python might count in a different way.
Exactly.
And then for the solutions on the Jake side, also the similar approach. We have a blocks, but blocks plus k.
Yeah.
So the current block and then the target value.
Jake seems to be only printing for now, in trying to sort of understand the question better, whereas Gibson was for a while there looking at the piece of paper he has for the question and trying to just probably think through in his head how he was going to answer the question, because they've already spent almost 5 minutes on this question, so it's taking time.
Yes, and I think Jake is starting to understand it might be a sliding window problem, and so that's why I think Jake is printing out a lot of stuff.
Oh yes, I see what you mean there. Like he's in the range, in his for loop, in the range part.
Yes.
He's subtracting k, so he knows that he needs to sort of
shuffle
iterate across without that value.
Shimmy, 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 shimmy along. What am I saying? Shimmy, shimmy. Yeah. Anyway, is back to Gibson's approach in this, which is taking the difference instead. So Jake is trying to do this sliding window, and Gibson is trying to do a difference from the minimum and the maximum of the blocks plus the k value.
And we've just heard that they've been given the first hint.
Oh.
We'll see if this helps any of them.
Oh, you never know, because last time the first hint was given, my God, completely delete all the code and then restarted it fully and then get it right.
Gibson out here now, running his code, getting 37 test cases. I believe that beats Jake.
Oh, that's gonna be quite interesting. I mean, Gibson is already way ahead, but you can't underestimate Jake also, because Jake has been proven absolutely legendary in the past few matches that he's presented. Well,
absolutely.
He coded it. But he has some failed test cases and he's trying to figure out what's the best way to do the sliding window.
Jake also trying to debug his code. Seems to be having some issues with maybe off by 1 errors, a very typical error.
And for this round, it would be the drone.
Yeah, the finals. The big grand prize. Well, of course there's the trophy.
And the printer.
A drone is pretty cool, and a 3D printer as well.
Oh, that's a lot. That 3D printer. I mean, what would you make in a 3D printer, Lucas?
There are so many things you could make. You can make, I don't know, your own phone case.
And
we have a win. That was rapid.
Jake absolutely won the first round, snatching the first victory away. But can Gibson catch back up into Jake's victory?
So now Jake has a point. They both move on to the second question. So Gibson lost all of his progress from the last question.
And Jake is currently now thinking, giving a different pose of, I'm gonna use all my brain cells. Yes. I mean, I can already see they are using so much thoughts and so much ideas going through their brains.
So now the next question is a fairly long and complex one, given it's the longest sub-sequence with a limited sum. So in this question, you're given an array of numbers, called nums, and an array of queries, called queries. And the goal is, for each query, to calculate the longest subsequence that adds up to that query value for each query. So then you have to return an array of all those values you've calculated. So it's quite a lot to do in a short amount of time.
I mean, this, the longest subsequence with the limited sum also has the longest example that has ever been presented in this whole show.
Absolutely.
And so this is quite a wordy question, if I have to say for myself, but
Gibson seems to be getting ahead and understanding that you have to write a function for each query. So he's already iterating over the queries.
But Jake is already also thinking about iterating the query also.
Exactly.
But instead
they're both sort of neck and neck with this one.
Yes, but instead of appending the values, the index values, Jake's just skipping over and just thinking about what conditions are needed to achieve the end goal. And that is quite a complicated question.
It is. Gibson with a nested while loop. We'll see what that does.
A nested while loop. You know something? I'm not a big fan of while loops.
How come?
While loops, you can easily break them. There could be just one case in that you can mess up your code forever.
This is true.
But for loops, you know your conditions. You know when to end, when to start. A for loop is so important in society, you know. And though if the sum of the left and the right is less than the query, it will be added on to another value.
As a wise man once said, a for loop is a promise.
Oh, I do agree with that statement. It is indeed a promise. And so yeah, so excited for who's going to win this round also. But if Jake wins, Jake will get another point, and making Jake only need one more round to snatch the trophy away. But if Gibson wins, it will start being a neck and neck.
Absolutely. Jake is in the lead now, but they have just both been given hints. We'll see if that changes the battle.
I'm pretty sure it will change a lot of the battles from what we've seen from the previous rounds, from getting the hints and being able to solve the whole thing in a thought process. I mean, those hints are very small. I've seen those hints. They are like literally like one sentence saying barely anything. It is not helpful. Well, it is helpful, but not enough to solve it completely easily. But they can think about it, they can articulate their thought processes to make a function work. That's quite impressive from both Jake and Gibson.
Yeah, it's interesting. So I had a go at this question myself, and the way I would approach it is I'd create a sort of, I'd convert your input numbers that you're given into, so I'd sort them from shortest to highest, and then you could make a list that has the accumulated values, and then you could it's just a matching problem of figuring out, okay, how many elements can you have that add up to the query maximum value? So that would definitely simplify and solve the question. But neither of them seem to have thought of that process just yet.
I mean, in that time pressure and also a competition itself and the nature of it,
exactly,
it would be quite difficult to think about stuff like it's way more complicated and complex in their hands.
I mean, Jake and Gibson are both running their code quite a lot to see if they can get some test cases. But it's just not enough to finish. There's clearly some bugs in their code.
Yes, but the approaches seem to be completely different. This is quite an interesting way of approaching it, like where Gibson is doing a for loop into a while loop of the less than the length of numbers, and the numbers is the new value. So for each index, that's a new value, and then this just goes through an instant. Why not use the for loop also in that case? Is that a specific reason why Gibson
I don't know. Gibson, I think, yeah. Well, Gibson and Jake are both using while loops, and I think it's because they've got a condition in there that they probably want to exit out of the loop when that condition is no longer met.
And then re-enter later on?
Potentially, especially when iterating to the next query.
Ah, I see. That makes a lot more sense than I anticipated. Okay, that would work better than a for loop, because for loop, of course.
Yeah, I mean, you can break from for loops, but that is more logic to add into. So potentially a while loop is more intuitive in that sense.
It would be, it's like if this, then continue. I mean, The prices, I really wanted it.
I mean,
round.
the stakes of this are quite powerful.
Yes.
So, a drone, having that like in the back of your mind of like, oh, if I win this, I'm going to win a drone. But like, it's clearly getting to them.
That is true.
Have you ever flown a drone before, Richard?
I have not flown a drone, but I would love to fly a drone. I mean, actually, I want to be on top of a drone. Imagine, right? Imagine you're like standing on top of a drone, and then just like you're having the remote in your own hands, and you're just flying everywhere. Like you're just delivering yourself everywhere. I mean, I'm pretty sure you can't do that.
I mean, people have done that. It's sort of like a flying skateboard almost.
Yeah, like a hoverboard.
But those things are pretty big to lift a human, you know?
That is true, that is true. Yeah. But the drone is not my favorite prize of this show.
Mm-hmm.
My favorite prize is obviously the 1995 film Hackers, starring John Lee Miller.
Absolutely.
And Angelina Jolie.
Jake and Gibson seems to be getting a bit closer. Jake, 49 test cases out of 56 done. They've only got 2 minutes left before this question times out and have to both move on to the next one, without anyone getting a point.
We can't seem to see what Gibson's test cases are, however... Oh, and
Gibson does it!
Oh,
wow.
And that gives an equal edge to Gibson, meaning both of them have 1 point.
1 on 1. Now it's on to the next question.
Oh, 1 for all.
Which is
for one.
A chess question.
Oh, yes, I love a good old chess. So for this question, you're given a 2D chess grid and a variable size of 2-dimensional array of integers. The integers represent the order of the chess knight pieces traveling across the grid in an L shape. And you need to check the order of the knight is valid, like you can check if this move is a valid move, and also remember the order. Yeah, that's it. That's the question, is if it's valid or not. But whoever finds out the list of validity in that list will take the W, and the other person will take the knight's L.
So because this question is only a binary return, you can just return false or true to see if you can get some test cases.
Yeah,
but
but
snatch those out first.
That's only going to get half of the test cases. That's not obviously not going to get all the test cases, meaning they won't be able to do it.
So this question is actually quite complicated to figure out. So you're, as Richard said, you're given a grid, a 2D grid with numbers on it. And those numbers represent the potential moves, well, the moves that a knight will take. So let's say you have 0 in the corner, then you have 1 somewhere else in the grid, then 2 somewhere else, 3 somewhere else, and so on. And you have to check from each position that from 0 to 1, the knight has a valid move. So like in an L shape, where it moves 2 in one direction and 1 in the other. And then, so from 0 to 1, is that a valid move? Then from 1 to 2, is that a valid move? And go all the way through the entire grid to check if the moves are valid.
Oh, one might say the knight is a massive tourist.
You might say that.
But I have a question. Does the chessboard contain any other chess pieces?
It does not. It is not even a chess grid, I don't think. I think the grid can be a variable size, as you can see in the examples. The first grid is a 5x5, and then the example 2 is a 3x3 grid.
Oh, I see. That's quite good. That's quite good. Anyways, the knight has to move in a set amount. To calculate each position, the first move will reduce the amount of moves the knight can make next. So to calculate that, that's kind of important. Like, whatever move the knight takes, the consequent moves will be also affected by it. Mm-hmm. Because if you take this move and it's to the edge of the board, then the possible ways you can do is up 1, down 1. But if you do it more in the center, there will be a lot more space to go around, going to 4 different locations.
An important thing to watch out for with this question is it does specifically state that the knight starts in the top left corner, so 0, 0 of the index of the grid. And so that would be a quick early return case you could check. So is the value 0 in the element 0, 0? Because that has to be checked. If it's not true and you find out that 0 is somewhere else in the grid and it is a valid knight move position, then and you return true, that's going to be wrong because it has to start in the corner.
Right, okay, fair enough.
And I don't think either of them have caught that out yet. They seem to be coding a lot. Gibson is really far ahead in some logic there.
Also, we're talking about more of the prizes. we got the drone, but the 3D printer. What would you like to print in a 3D printer?
Oh, there's so many things you could print. As I said, you could print a custom phone case, you could print a keychain, you could print another printer.
Printing a printer that prints a printer that prints that printer that printing that printer.
Exactly, infinite printers.
Oh my lord, printerception going on here. I mean, or maybe you could print out the Coders Cup 2026 and just win like that.
You definitely could.
But is that the right way of winning, Lucas?
I don't think so.
Oh, this the only way to find out is the finalists fighting each other. And
Only
trying to
12
win.
minutes left in this final. This is a long game.
This is a long game. I mean, I see Jake has set a 2D array of all the offsets.
Yeah.
And from the offsets, we take the knight's X and Y position.
So what Jake seems to be doing is, so he's going to iterate through every single position of their valid moves, and then he's going to check, okay, is the offset from, I don't know, index 0 to index 1 in that offsets loop, in that offsets array? And if it is, well, it's a valid move. If it's not a valid move. And we've just heard they've been given a hint.
Oh, a new hint. That means, well, you know what that means? That either Gibson or Jake are gonna snap it through. Like, they're just gonna snap and it's done.
Well, we'll see. The last few games when they've been given hints, it hasn't seemed to do too much.
But you do have to say the last round of this finals, Gibson did get a hint and managed to solve it relatively fast after receiving the hint.
This is true.
So this is not necessarily like, I mean, the hints do help, but they are not necessarily a big game changer. They are just meant to be a slight nudge towards the right direction.
Gibson seems to be debugging his code with some print statements to try and figure out what's going wrong. Jake over there also implementing some break logic for some early returns. I wonder what that's for. I guess if it finds out that a move is not valid, then you can return early because you know it's wrong.
I mean, you can also check all the different moves, and then from that point onwards, you can kind of cut down on how many valid moves you can make. And I think I have mentioned this before, but imagine moving the knight to the edge of the board, comparing that move to the moving into, I don't know, the center or into another corner. That is quite, again, I think that's what Jake might be also considering into the...
Yeah, both in deep
statement.
thought here, trying to debug their code, figure out what's not working, how they're misunderstanding the question potentially.
So Jake sets an offsets, but Gibson doesn't. But Gibson does not do the offsets also. Gibson just straight up just skips the offsets and just looks at from the arguments instead.
Yeah, only one more minute for this question. This is coming down to the seconds.
Yeah, it seems like neither of them can take the L with the other knights. It's like they are fighting with knights in the code.
Literally.
There is a one-on-one battle. The most intense battle of all time is happening right here, right now. Lucas, this could be the greatest chess battle ever to be created.
Well, I think programming and chess are quite a different competition, so I wouldn't confuse the two.
Oh, that is true, but it is chess related, and guess what? You can never see that bishop coming. No one knows where the bishop comes from. That
I don't
code.
think there's any bishops in this code, Richard.
Ah,
I mean,
that's
maybe there
unfortunate.
is. Maybe that's the bug they're encountering.
Aha, that makes a lot of sense.
Anyway, Jake wins on use cases, test cases.
Yes.
So on to the next question.
And you know what this means? Jake only needs one more question to snatch the trophy away like BAM! And this is the count of number of vowels in a string in a range.
So this question is actually quite simple when you understand it. So what you're doing is just, you're given an array of words. And so you go through each word. Does it start with a vowel and does it end with a vowel? If so, if that's the case for every single word, then you return the number of words with vowel starting and vowel ending. So for the example case of you've got the words R, Amy, and you, well, R has an A and an E at the start and end, so that's a valid vowel word. Amy only has an A at the end, a Y is not a vowel, so that is not counting towards the total count. U, it starts with a U and ends with a U, so
would you count that?
Counts.
Would you count that as a word though specifically? OU is just a letter. I mean, I guess you can use it.
I mean,
like,
it is a word according to the rules.
Okay, so a single letter is a word. I guess the
These
word
are things
A,
to watch out for.
That is a very small case, but it works out.
So in that example case, the output would be 2, because there's 2 vowel words.
In that sense, it's just to check the first character and the last character.
Yeah, exactly.
And check for the string.
Oh. And like I said, it's an easy question. Jake ahead. And Jake's won!
Jake has won! Jake has won the Codescope 2026! I did not expect that. That was out of nowhere. We were just looking at the question on how would he approach it, but it seems like Jake has won the Codescope 2026. This is amazing. Congratulations, Jake. We will pass it over to Studio 2 to see how you feel about this.
Congratulations, Jake! You have just won the Coders Cup 2026. I'll let you take a moment to let that sink in and come to you in a moment. Unfortunately, Gibson, you have made it so far, but you've knocked out in the final round and taken second place. Congratulations to all of your hard work, and anything you want to say?
Clearly, I haven't done enough leak codes. Yeah, I'll be back next year.
And I can't wait to see you next year. That was a great run. You guys did absolutely great, and it wasn't 3-0. You still got something, so that was definitely great. But you won't be going home empty-handed. You get everything all the other contestants who have come down today get so far, except for the 1995 film Hackers. So here is your goodie bag, plus a 3D printer. Wow! Thanks for coming on the show. Back to Lukas and Richard. I think I might have done that wrong. You didn't get that DVD.
So that was a very impressive match.
That was indeed a very impressive match. And this has been a crazy journey just happened right now. And we've just experienced history being made right here.
Well, let's see the journey of the winner. Let's see the leaderboard.
Yes. Let's go back to the brackets. And as we can see, that Jake started with Jessie going up into Ella's battle and battling Ella. Ella unfortunately lost and went to the third place.
And then Jake into the finals against Gibson.
And though Gibson has shown how strong of a programmer they are, like it has been absolutely, you can see the thought process of Gibson and Jake also.
But clearly Jake was just understanding the questions faster, being able to get code out faster and complete them, and in the end, win.
It's the process of articulating the questions, because the questions are worded in a hard way to prevent the coders to easily solve them.
Yeah,
obviously,
exactly.
Certain questions are hard.
But those were some hard questions. They were taking their time with those.
I mean, the chess one, the knight one, that was a very, very difficult question. I was still stuck at trying to figure out how I should approach the questions. I know, Lukas, you already know all the possible ways to solve it.
Well, let's get back to Zee, who's with our winners now.
Congratulations again, Jake, for winning this year's Coders Cup. Is there anything you'd like to say to your adoring fans out there watching you?
Thank you for supporting me from the beginning, all my fans in chat. I'll be back next year to defend my title again. And I'm going to win it again next year, I reckon.
We love that confidence. You've had a great run. Now, of course, I think we can all agree being crowned the best programmer of Sussex is a prize enough in itself. But that is not the only prize you're going home with today. You are going home with the HackSussex tote bag and shirt and mug, which everybody who came down today also received, as well as the Atari Games console, 3D printer, and of course, the drone. How does all of that sound?
I get all 3 of them.
Yes.
Ow, my eBay is going to be looking stacked.
Oh, what? No, you're gonna have a time when you get home to play with all these new gadgets. Of course, even all of that, there is one more thing that you get to take home. Without further ado, I think this belongs to you. But we have one last surprise for you.
Oh, Layton, the winner of the Coders Cup 2024, has come back and tried to defend his crown and that cup. How dramatic.
I wonder how this will go. Let's have a look at the matchup.
Well, you see, we have Layton, our last year's winner, and Jake Morgan, who is now with the absolute vodka. And you see, Layton has 6 years of programming experience, but Layton is actually really, really good at programming already, as we've seen in the 2024 Coders Cup.
But Jake has proven himself this time.
Jake has proven himself, but you see, Layton might have been just on a different league.
I guess we'll see. I wonder who's going to walk out of here today as the winner. Let's see what Layton has to say for himself. Over to you, Zee.
Layton, it's so wonderful to have you back. How are you feeling being back on the Coders Cup?
It's wonderful to be here. Wonderful to see everyone again. Can't wait to win.
We love the confidence. Are you ready to defend your title as the last reigning Coders Cup champion?
Definitely.
We love it. And Jake, how are you feeling being up against our surprise guest, the last Coders Cup champion?
I'm not scared of him and his little ginger head. He's going down.
We love the confidence. The room is full of hair. Truly, for the final time today, take your seats, champions. I'll hold that for you whilst you guys have your last and final ultimate competition. It's getting tense. They are closely matched. We have last year's winner versus this year's winner. Layton defending his title and Jake defending his title that he's just won today. I wonder how this is gonna go, but honestly, Jake's made it this far. I have hope. And Layton, good luck to the both of you. Get ready to compete in 3, 2, 1, code!
And it's the bonus round, Layton versus this year's winner.
Yes, and this question is an incredibly complex question. Haha,
Layton jumping ahead, trying to return just a Boolean value. He gets half the test cases, but it's not
Jake
enough.
already figured out the question. And Jake has
Jake won straight away.
So speedy.
He got that.
Yes, Layton had no chance against this year's winner.
Now that question was it sounded hard, but in truth, as you saw, it was actually quite easy.
Yeah. And I mean, let me read out the question for you. 2 players take turn in a game where the number of chalkboards and your turn subtract any proper divisor from your current number and you'll lose. You can't move. If you can't move, Alice win assuming the optimal play. That's a very wordy question.
Yeah, so it's sort of the question is disguised as like, oh, it's player versus player, you've got to calculate these values between players and players, but in truth it's just is the value even or odd? So yeah, that was very interesting.
Odd or even or odd, either way, Jake won.
Well, over to Zee for the last time to hear from Layton and Jake.
Yep.
Wow, that was amazing. Jake, that was so quick. What did you think of that?
Well, I saw the question and it looked pretty complicated. So I knew you had to return true or false, and it's one of those like stupid questions, right? Where you're probably just moduloing it. So I kind of guessed, was an educated guess, I'd say. It's a bit unfortunate for Layton that he had to lose in such a pathetic manner.
Wow, that was so fast. Layton, how are you feeling after that? That was really quick.
Yeah, it was.
Did you even get to start typing?
No.
Wow, guys, that was I would say intense, but that was so quick. Our head spun in this studio. That was absolutely crazy. Well done to the both of you. Unfortunately, Layton, you couldn't defend your title. But Jake, you just beat our champion from the last Coders Cup. How do you feel?
Accomplished. And if anyone's watching in chat that is looking for people for summer internships, I need a summer internship. So message me or the uni. Yes. Or if you know someone that's recruiting, message them and send them that last round. And yeah, I'm hired. Please.
We're all for the self-promotion. That was absolutely amazing. Well, that's it from me. A huge congratulations to our contestants here today. I hope you all had fun. I definitely realized that I need to study. So over to you, Richard and Lukas.
Well, a massive thank you to every button masher who participated in the qualifiers, as well as here in the studio.
Oh, I almost forgot. Congratulations, Shadow Kretzel, who won our second Steam voucher. DM us on Instagram to claim your prize.
Wow, it's game over for the HackSussex Coders Cup 2026. What an impressive lineup we've had. Another huge congratulations to our big winner, Jake. Crazy to think we're all finished.
Each contestant was fighting with their best kit and abilities, using every item in their arsenal, showing their true talent. Raw talent was shown everywhere in the show, shining from each contestant.
They've all managed to give us an amazing show, but we couldn't have done it without our generous sponsors Unity, BCS, Switchplane and the Department of Informatics at the University of Sussex.
And we can't forget to give a huge thank you to Kobe and Josh in the Media Technology Lab for letting us use their studio to bring you the live finals today.
And we have to give thanks to HackSussex Committee for putting in hard work behind the scenes. Last but not least, all of you, yes, you the audience, for tuning in. That's all from us, but don't turn off the stream just yet. First, we'll hear some final words from our president, Charlotte. And then we have one more thing for you, a classic blooper reel.
Yay, blooper reels!
All right then, it's bye from me, and I'll see you at the pub.
Cheers!
Before we continue, I want to take a moment to talk about something important to us. Running a society like HackSussex is hard work, and that means we're constantly on the lookout for talented and inspired people to take HackSussex even further. Whether that's running hackathons for your fellow students, hosting workshops on topics that interest you, or being behind the scenes in shows like this, and we have a place for you. We'd love to have you join our team, so if you'd like to get involved and are a current or incoming University of Sussex student, then please reach out to us on our socials linked below. As president, I have to say a huge thank you to the committee this year. The amount of time, effort and care that goes into everything we do is incredible. None of this would be possible without them. A lot of what happens behind the scenes never gets seen. The late nights, the planning, the problem solving when things don't quite go to plan, and it's those things that make events like this possible. Being part of HackSussex this year has been an incredible experience, and it's been great to see so many of you get involved. I'm really proud of what we've put on together, and I'm looking forward to what comes next. As we wrap up today's show, we want to take this opportunity to thank the amazing HackSussex community. Whether you attended a weekly social, joined us at a hackathon, or are with us here today in the studio, we want to say thank you. If you attended your first event with us this year, thank you for saying hello, and we truly look forward to seeing you again next year. For those of you who have been with us for years, attending events time and time again, an extra special thank you. Keeping our events fresh and exciting takes an enormous amount of work, so we're incredibly grateful for your continued support and loyalty. For now, we're saying goodbye. We hope you have a wonderful summer, and we can't wait to see you all next year for another incredible season of HackSussex.
All good?
Society. Since our founding back in 2012, we've been at the heart of the university, running events for students all across the country. This year,
big brain.
Oh, this is on camera.
Hi. Whoa, he's recording.
That's terrible. As well as our lung. Was that the first one?
Let's take a look at what is in.
With
We're proud to run.
Before we officially start the Coda Cup, Coda Cup.
absolutely blown away by the. What are we blown away by?
I can't floss, so like if I try, wait, it's like,
That's all I know. Anyway, nice B-roll clip.
Casey, the blooper, you know, it's pretty good.